In this video, we will discuss net ionic equations in aqueous solutions. Let us see what are net ionic equation. The net ionic equation is an equation for a reaction in solution that shows only those particles that are directly involved in the chemical change. And it is balanced with respect to both mass and charge. So we should know what are aqueous solution. Aqueous solutions are nothing but a solution prepared in water. So why is it important to learn the net ionic equation? The net ionic equation shows only the species that are responsible for the chemical change in the aqueous solution. So when you mix two aqueous reactants together, if there is a color change, which are the ions involved in that process? If there is a solid formation, that's a chemical change, right? So what is the reason for that solid formation? If there is a gas production, what is the reason for that gas production? Which are the ions responsible for that? So that is what is shown by net ionic equation. So which ion is responsible for the formation of precipitate here, the yellow solid here? Is this ion responsible, or is this ion responsible, or is this ion responsible, like that? So on a chemist point of view, it's important to know which ions are responsible for this chemical change. So we can see that this is the solid formed here. So only lead ion and iodide ions are responsible for the reaction. So irrespective of the source of lead ion, irrespective of the source of iodide ion, whichever the two chemicals that contains these ions combine, the chemist is going to see that, oh, okay, this reaction is going to happen. So it's not necessary that we have to take potassium iodide for iodide source. And it is not necessary that we have to take PbNO3 twice in order to get Pb ions. So that is what shown by net ionic equation. It is, on a chemist point of view, it is very important. Which are the ions responsible? So the chemist can choose any source that is giving those type of ions for the reaction. Here is another example for that type of reaction. When sodium chloride and silver nitrate mixed, there is a white precipitate formed in the beaker. So which are the ions responsible for that reaction? That is, only silver ion combines with a chloride ion. This is from sodium chloride, but it doesn't matter. It can be from KCl. And this is from AgNO3, but it doesn't matter. Any Ag ion, silver compound can be combined, that is soluble in water, can be combined in order to get AgCl. So in a complete equation, normal balanced chemical equation, we will write, if it is NaCl plus AgNO3, we will get N-to-N combination and this combination, right? Center to center. So NaNO3 we will get, and AgCl we will get. This is the complete equation. This shows that, okay, these are the two chemicals I mixed and I got AgCl as solid. That is the reason for the chemical change. This is the equation for that whole reaction. But depends on the details the chemist need. He needs to know, or she needs to know, only which are the ions responsible for that chemical change. So that is what is the net ionic equation. So irrespective of the source, the chemist can form this product. So that is what is simplified by the net ionic equation. So what is the final equation for that product formation? Okay, so that is what is net ionic equation is. That is why it is important. There are three major types of chemical reactions in aqueous solution, which are, first one, as we have just seen, precipitation reaction, right? That is the one we have seen. And another one is acid-base reaction. Acid-base reactions are the reaction between an acid and a base. And the third type of aqueous reactions are redox reaction. One of the reactant is getting oxidized and the other one is getting reduced. So oxidation, reduction reaction, or redox reaction. So these are the three types of aqueous reactions that we have to learn how to write net ionic equations. So let us see with an example how to write net ionic equation. Normally we follow these three steps. Okay, so we will first write a complete molecular equation, which is our regular balanced chemical equation. So for the previous example, when we combine sodium chloride, which is dissolved in water, so we will write AQ in parenthesis, which combine with the silver nitrate, which is also soluble in water. So we will write AQ in parenthesis. AQ means aqueous. So then we are getting the product N-to-N combination. So that is first NaNO3, which is going to be soluble in water, and then Ag and center to center, Ag and Cl, always write the positive ion first. So that is why we are not going from this side to this side. So AgCl, which is a solid. I will explain how to decide which one is aqueous, which one is solid using the solubility rule chart, uh, which will be discussed in the next slide, upcoming slide. Okay, so after writing the molecular equation, we will write a net ionic equation. So complete ionic equation. So we call it as molecular equation. And the complete ionic equation is like this. For the complete ionic, we will write the ions. When sodium chloride is dissolved in water, we have seen sodium ions will form, chloride ions will form. And silver nitrate also will dissociate into silver ions and nitrate ions. Okay, and then on the product side, again, we will have sodium ion and NO3 ions. And AgCl is a solid. Solid will not be in the ionic form, so it is going to be solid as such, we will write. Okay, so in the liquid, all the ions floating around are sodium ions are there, chloride ions are there, NO3 ions are there, correct? And Ag ions are there. All these are floating around except AgCl, which will be the solid at the bottom. Okay, so that is the picture of it. And then cross out the spectator ion. What are spectator ions? Spectator ions are the ions that appear on both sides of the arrow mark. So I can see when I rewrite this one to show you the spectator ion, I can see the sodium ions are same on both sides, NO3 ions are same on the both sides. So what I will do, just cross that one out. So Na plus is here, Na plus is here, and I have NO3 minus, NO3 minus. What are the things left on the left side? We have two ions. On the right side, we have a compound. Okay, so that is the one we are going to write it down here. So that is, we have Ag plus and Cl minus on the left side of the arrow mark, and on the right side we have AgCl solid. So this is called the net ionic equation, or this is the complete ionic equation. Okay, so these are the three steps we are following when we write the net ionic equation. Like solids, gases, and pure liquids are not going to ionize, and weak acids are also not going to ionize. So whenever you see S in parenthesis, do not ionize that compound. Whenever you see G in parenthesis, do not ionize, and L, do not ionize, and weak acids will not ionize. Okay, so these points you should remember while writing net ionic equations.